Hi everybody and welcome to this video. In this video, we're having a look at another tool that helps us with our probability, and that is the use of tree diagrams. So tree diagrams allow us to again deal with or study compound events or more than one event. Unlike our two-way table, it allows us to look at more than two events as we can just continue the branches of our tree. So here we have an example which we will analyze using the tree diagram. So there's a bag of sweets, and here's the bag of sweets. There are 3 green sweets and there are 5 red sweets, and we have to pick 2 sweets without replacement. So once we've taken a sweet, that sweet is no longer in the bag, and that's important information. So what we're going to do is we're going to split our event into our 2 parts. So our first event is drawing the first sweet, and our second event is drawing the second sweet. So here you can see the branch. Now when we're picking our first sweet, we have 2 options. Either we can draw a green sweet or we can draw a red sweet. Those are the only 2 options available to us. On the tree diagram, it's also common to add the probabilities associated with particular events. So what is the probability that in this box, this bag, we pick a green sweet? Well, in total, there are 3 green sweets. So there's 3 ways that we can get a green sweet over the total number of sweets, which are 8. So the probability of us getting a green sweet is 3/8. The probability, the probability of us getting a red sweet is then, there are 5 red sweets, so it's 5, and the total number of sweets is still 8. So there, on our tree diagram for the first event, we've included all of the options and the probability of you getting those options. Okay, so now let's move on to the second event. Now this one is done without replacement. So let's go through the green branch. So once we've taken out a green sweet, there is 1 less sweet and particularly 1 less green sweet. If we are picking our sweets again, there are 2 options. We could pick a green sweet again, or we could pick a red sweet. What is the probability with picking a green sweet? Well, now there are 2 green sweets left because we've picked out 1. So there's 2 options to pick out. And instead of the total being 8, the total is now 7 because there's 1 less sweet. The probability of you picking a red sweet, there's still the same number of red sweets because we did not pick a red sweet, we picked a green sweet over 7. So please take note, how does the first event affect the second event? Okay, so then let us have a look at if we had chosen a red sweet, what would happen? So red sweet again, we could then pick a red or a green sweet again. So if we picked a red sweet first, the probability that we pick a green sweet next, there's still 3 green sweets, and in total now there's 7 because there's 1 less sweet. If we picked a red sweet first, what is the probability we pick another red sweet? So if we picked a red sweet, there's 1 less red sweet, so there's going to be only 4 red sweets, and the total is also now 7. So there we have our tree diagram. So in a tree diagram, we indicate the outcomes and the probability of those outcomes. So the different outcomes that we could have gotten if we combine them is you could have gotten a green and a green sweet, so 2 green sweets. You could have gotten a green sweet first and then a red sweet, so green, red sweet and then a green sweet, so red, green, and then finally red and red. So those are our outcomes. Now, if we wanted to calculate the probability of a particular outcome, then we multiply the probabilities to get that we have to use to that root. So for example, the probability of green, of getting 2 green balls, that is equal to 3/8, the probability of getting 1 green ball, times 2/7, the probability of getting the second green ball. So that, if we just simplify, is 6/56, which you can then simplify to 3/28. Okay, so what is the probability that we get? Let's say order is important, so it does matter which one we choose first. So what's the probability that we get a red sweet and then a green sweet? Okay, so that means we probably multiply the probabilities of that. So red first is 5/8, and then us getting a green sweet after is 3/7, which is 15/56. So please make sure that you understand how to, first of all, draw the tree diagram indicating the probabilities of getting it, list all of the outcomes, and then be able to calculate the probability of each outcome. Okay, let us have a look at an exercise. So it says repeat the exercise assuming the sweets are replaced after each draw. So before, the sweets were not replaced. So now if we're replacing them, okay, what's the probability that we get a green sweet and what's the probability that we get a red sweet? Well, it would stay, the first step would pretty much stay the same. There's 3 green sweets and 5 red sweets. So 3/8 and 5/8. But now our second draw would change slightly with the replacement. So we're putting that green sweet back, or we're putting another green sweet in its place. So then what is the probability that if we took a green sweet, we get another green sweet? Because it's now replaced, there's now 3/8 sweets again, 3/8 green sweets. Okay, and for the red, it's 5/8. For the second one, if we take the red sweet, and then probability of choosing a green sweet is 3/8, because we've replaced the one that we've taken out, and 5/8. So please take note that if we do it with replacement, the probabilities stay the same. If we do it without replacement, it changes as we go along. Okay, so our outcomes are still the same. We can still get a green and a green, we can get a green and a red, we can get a red and a green, and we can get red and red. So our outcomes are still the same, but the probabilities of those outcomes change slightly with and without replacement. So what is the probability of getting a green, 2 green balls in sweets in this case? It's 3/8 times 3/8. So we still multiply the different branches to get the probability. So it's 9/64. What is the probability of green and then red? Well, green first is 3/8, and then red is 5/8. So that's 15/64. Okay, I hope that has made sense and that you've understood it. Please try and use a tree diagram to represent more than one, and make sure that you fill in the probabilities and understand how to calculate the probabilities. Please watch our other videos for more information on probability, and thank you for watching. Bye.